Hello, today I'm going to discuss two functions of x and y, x plus y minus x times the absolute value of x plus the absolute value of y, set that equal to 1, and then f of 2, or f2, which is negative 2x plus y minus y times the absolute value of x plus absolute value of y, set those equal to 0. I'm going to show why when these two are equal to 0, they only have solutions in this case between x of negative 1 and 1 inclusive, and here strictly between y of negative 2 and 2. And the first thing that I'm going to do is show that both of these functions are odd. Right now they're implicit functions since they're of x and y. And so when you have an implicit function, f of x comma y, if you have that equal to f of negative x negative y, that means that it's odd. Basically, that if you rotate it 180 degrees around the origin, intuitively it looks the same rotated that way. And this will be really easy to see if these two functions are set equal to 0. How if you substitute negative x for negative y, this will be unchanged. This will be unchanged. Everything else will just swap out a minus sign. And since that's set equal to 0, you can just multiply everything by negative 1, both sides, and recover the original functions. So what that tells us is that the behavior of the function in the first quadrant is a mirror image of the behavior of the function in the third quadrant, and likewise for the second and the fourth. So whatever domain and range restrictions we see for positive x, positive y, we'll see the same for negative x, negative y. So what we'll do first is show that in this first function, f of 1 or f1 of x, y equal to 0, this only has solutions for x from negative 1 to positive 1. And the way that we'll do that is first, let's say that x equals 1 plus some small epsilon. And this will tell us if our 1 is a tiny step to the left or a tiny step to the right of 1. So we'll go ahead and make that substitution. So subbing out 1 plus epsilon for x, we have 1 plus epsilon plus y minus 1 plus epsilon times the quantity of absolute value of 1 plus epsilon plus absolute value of y. So then we'll expand this out. We have 1 plus epsilon plus y minus 1 plus epsilon minus y minus epsilon times 1 plus epsilon minus epsilon absolute value of y. And then these are still equal to 0. Now, 1 plus epsilon, this is always going to be positive, so it will be minus 1 minus epsilon. This will become minus epsilon squared. But since epsilon is small, we'll just say that that equals 0. And now we go ahead and take care of everything else. So this cancels out with this. We have y minus absolute value of y minus epsilon absolute value of y equals 0. We'll put this on the other side and factor out the epsilon. We have y minus absolute value of y equals epsilon times 1 plus absolute value of y. And then we have epsilon equals y minus absolute value of y over 1 plus absolute value of y. So now we'll evaluate what epsilon can be. So for y greater than or equal to 0, we have y minus absolute value of y. That equals 0, which means that epsilon is equal to 0. Then for y that is less than 0, y minus absolute value of y over 1 plus y. That is the same thing as writing 2y over 1 plus absolute value of y. And since y is negative, that means that 2y is negative. And then 1 plus absolute value, that's always going to be positive. So that means that this is going to be less than 0, which means that epsilon is less than 0, which means for y, big to small, you have epsilon greater than, or sorry, less than or equal to 0. And since we have x equals 1 plus epsilon, then we have f of x, y equals 0 only if x is between -1 and 1 inclusive, because we can have epsilon less than or equal to 0, which means that x is 1 or less in the first quadrant, and then -1 or greater in the third quadrant. So next we'll do a similar analysis of F2. And I'm going to show that for F2 equals 0 to have solutions, we have to have y between -2 and 2. And the way that we'll do that is very similar, saying y equals 2 plus epsilon. Go ahead and make those substitutions, -2x plus 2 plus epsilon minus 2 plus epsilon times absolute value of x plus absolute value of 2 plus epsilon, 2x plus 2 plus epsilon minus 2 absolute value of x minus, we'll just set this is 4 minus 2 epsilon minus epsilon absolute value of x minus 2 epsilon minus epsilon squared. Since epsilon is tiny, that becomes 0, and then we'll just go ahead and collect everything else up. We have plus epsilon minus 2, so that's going to be a -3 epsilon. We have a -2 times x. 2 minus 4 is -2, and then factor out that to get 1 out here, and then a absolute value of x. All that's left is a negative epsilon absolute value of x, set that equal to 0. Make sure I have everything. Yeah, cool. And then we'll just move this to the other side. We have -2 times x plus absolute value of x plus 1 equals epsilon. We'll factor this out. Absolute value of x plus 3. Then epsilon equals -2 times x plus absolute value of x plus 1 over absolute value of x plus 3. Now for x greater than or equal to 0, the quantity of x plus absolute value of x plus 1 is strictly greater than 0. Absolute value of x plus 3 is strictly greater than 0. Therefore, epsilon is going to be -2 times this quotient. So a positive divided by a positive times a negative will always be a negative. So that means epsilon must be less than 0. Now for the other case, epsilon being less than 0, x plus absolute value of x plus 1 just equals 1. And then absolute value of x plus 3 is always going to be positive. So then we have a positive divided by a positive times the negative multiplied by the -2. That also implies that epsilon is strictly less than 0. So since epsilon must be strictly less than 0, y equals 2 plus epsilon must be strictly less than 2, which then gives us the range restriction for F2 of x and y equal to 0. the y must be in between -2 and 2. So that is the two proofs that for these two systems, if they have an intersection, it must be between x, -1 to 1 inclusive, and then in between y of -2 and 2. There you have it. Thanks for checking this out.